Are you ready, peeps?
I, teacher.
I can't hear you.
I, teacher.
Ooh. Who wants to learn fluorescence spectroscopy?
We are teacher.
Used to measure photon intensity.
Fluorometer.
If explaining it simple is something you wish,
Go watch and learn.
then drop what you do and watch like a kid.
First year bio.
Fluorescence spectroscopy. Fluorometer. Now we'll be explained by teacher Jhoebe. Ha 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 ha.
The trust.
The exploration of lighting technology is based on the solid understanding of the fundamental principle of luminescence. Luminescence is referred to the cool emission caused by the movement of electrons within a substance from high energetic state to less energetic state. With that, it gives off light at normal or cool temperatures without generating heat. There are several types of luminescence. Photoluminescence is when light energy or photons stimulates the emission of a photon. Chemiluminescence is defined as when chemical energy is responsible for the emission of a photon. One example of this is bioluminescence as seen in fireflies and many marine forms of life. Electroluminescence, on the other hand, is when electrical energy or strong electric field stimulates the emission of a photon. This is seen in some lighting applications. Moving on, fluorescence is a type of photoluminescence where light raises an electron to an excited state. The excited state then undergoes a rapid thermal energy loss to the environment through vibration. This results for a photon to be emitted from the lowest lying singlet excited state. This process of a photon emission competes for other non-radiative processes including energy transfer and heat loss. When the term fluorescence is used, the same method for measurement can typically be applied to any of the above categories of luminescence. But in what ways are the light being measured? Fluorometry is a method of identifying and analyzing sample based on the light absorbed and then the light emitted of a sample or analyte. Did you know that there are several types of fluorometers? The filter fluorometers, which passes the light through filters, the integrated fluorometers, that is the world's most automated and advanced combined photosynthesis and chlorophyll fluorescence system, and then what we are going to talk today, which is the spectrophotometers. These are the fluorometers that passes light through diffraction grating monochromators. Moreover, spectrophotometers use a steady state of fluorescence spectra that when molecules are at constant light, they emit fluorescence photons. These emitted photons are then detected as a function of wavelength to be scanned and be plotted using an intensity rate of an instrument. Then, can you name an instrument? Of course! One of the examples of these instruments are the Hitachi F2700 Fluorescence Spectrophotometer. The features of this instrument are high performance and support reliable data, wide application on quantifying analytes on material, biological, and environmental fields, and easy operation. If you seek any information about this instrument, you can check at the comment and there's the link of the brochure. Now, we will get a grip to the main principles of fluorometry. But first, you must understand the components of fluorometers. In general, all fluorometers has three main basic components: a source of light, a sample holder, and a detector. In our case, with spectrophotometer of Hitachi F2700, the main components are the light source, which is the xenon flash lamp, monochromator, both excitation and emission monochromators, a sample holder, a detector, and an emission interpreter. So to fully embrace the topic, we will now study how light travels inside a fluorometer or spectrophotometers. A beam of light travels in a single optical path. In this case, our source of lamp is the xenon lamp. The light emitted from the source passes a curved lens and allows to focus its direction to the excitation filter or the excitation monochromator. The excitation filter or the diffraction grating excitation monochromator allows only UV light to pass through. The UV light is diffracted at an angle to avoid the possibilities of visible light passing through the filters. Once again, the light passes through a lens focusing the filtered UV light to the sample or the cuvette, where the analytes is placed. Here, the UV light is absorbed by the sample molecules. The light in which coming out from the sample holder contains fluorescence light and may contain original UV light. The emergent light from the sample holder is then analyzed at a 90-degree from an incident in order to avoid the mixing of reflected or transmitted light with the emergent light. This emergent light, which is supposed to be fluorescent light, is then allowed to pass the secondary filter or the emission filter that will absorb any UV light. Now, the emergent light is only fluorescent light and then projected at an incident directing to the detector. This detector is connected to a photocathode of digital display which gives us the intensity of fluorescence in the sample. To finally sum up, I would like to remind everyone that every material or compound to be tested has different levels of excitation. I hope you have learned something today, and I hope you had a great day. Thank you until we meet again.